Hello everyone, I am going to continue the next section of information theory. Information theory. In last class, we have already studied about the information. It actually represents the surprise element in a particular information, which is called as message. So we have also seen its mathematical modeling. Ixi minus log 2 pxi. So this part we have already completed. Now moving towards our next section, if I am going to say that if receiver knows the message being transmitted, the amount of information carried is, this is a question also, if receiver knows the message already, then what will be the amount of information? If receiver knows the message already, then pxi will be automatically equal to 1. So what happens? The amount of information we are going to calculate, which is again from this expression, minus log 2 1, and again I will rewrite it in terms of base 10, log 2 log base 10 1 over में log 10 2. Then this whole expression becomes 0, which we were talking about, and this is proved also. Hence proved, if a particular message with probability 1 we receive at our receiver end, then the information content will be 0. So continuing this theory, we can move forward. This is not so much difficult section, but its minute points are required to be noted because it's an important branch of digital communication also. In the continuation of same part, if I am going to put forward a question like Ixi, information carried by a source symbol x. This is if xi symbol is carrying information Ixi. Then what about Ixi? X1 symbol is carrying Ix1 information, Ix2, X2 symbol. This is given in a particular question. So what we have to prove, Ix1, Ix2 equal to Ix1 plus Ix2. So point to be noted here, this we can prove only if x1 and x2 are independent events. They must be independent events, so that we can prove this much of expression. Now moving forward, I can rewrite the information content of Ix1 and Ix2 like this: log 2 1 over px1 px2. I can rewrite it as px1 and px2. What happens with some log properties? I can rewrite it as log 2 bracket 1 over px1 1 over px2, and again I can rewrite it as 1 log 2 1 over px1 plus log 2 1 over px2. Hence this expression is true because this again holds for Ix1 the probability distribution, the x1 symbol is carrying, and this again holds for probability distribution, the x2 symbol is carrying. So we have proved this expression. Now this is about some common problems we have to do in information theory section. Now we can move forward towards our next section. The next section is very much important. Up till now we have studied about information. Now the next section is about entropy. Entropy, as the name indicates, we can also define it as average information. Now this term is very important. Practically, we are not interested in one symbol transformation of information. We actually require long sequences of information. So what I am going to explain here is very important. Average information we can evaluate with some mathematical entity. As we are not interested in one simple information, we have to generate a long sequences of simple information at receiver end. So what we can do for this? So if I am going to say the mean value of the information that xi symbol is carrying over the alphabet source x with m different symbols, so I can write it as hx mean value represented by EIXI. This is the average information I am going to calculate. It is also called as mean. Mean of the information content of any symbol. So what happens? I can calculate if there are m different symbols, I can rewrite its form as I1 to m, the information starting from the 1 initial position to m the final position with the probability distribution Pxi and Ixi information source. And as we all now up to this section, we came to know about the information content of any symbol is, I am writing the expression as we have already completed. The information content log 2 Pxi, and its unit is very important. Bits per symbol. Now this is again an important factor to note down, that is entropy, average information content at any receiver end. We can get from the expression the initial position is 1 to the final position f, if m symbols are there, m different symbols are there, to the evaluation of Pxi and Ixi. I have just written the expression of information content. Now it will be more clear with an example. Any definition can be clear with some kind of example. So we should always focus on the examples also. If we have a binary source, in binary source what happens? 0 or 1. This means a binary source, and we have to calculate its entropy. And what is the entropy of binary? If its probability we are going to talk about, that 0's probability will be half, 1 probability will be half, because we have a binary source and we have to calculate in simply entropy. We can write it as, I am using that expression, I1, initially it will start with 1 and times 2, because only 2 numbers are there in a binary source, and Pxi log to Ixi. What I am going to write? I am just going to expand this expression. Minus half log 2 half minus half log 2 half. So when we will solve this expression, we will get 1 bit per symbol. The entropy of binary source we calculated here. Now the important thing we are going to note down here, what is its upper bound and lower bound. The source entropy must satisfy the following relation is 0, it should be must greater than 0 log 2n. This I am going to prove in the next section also. Before that we have some important terms also that we are going to cover. So I am ending with this topic here. I am going to say two most important things about it. The lower bound corresponds to no uncertainty, which occurs when symbol has probability 1. Which corresponds when symbol has probability 1. And the upper bound to maximum uncertainty, which occurs when pxi equal to 1 by m for all I, when all symbols are equally likely to be transmitted. So I am going to end this topic here. We will again see this topic in the next class, and if any sort of confusion queries come to your mind, please let me know.